Hello students, today we will be studying TIR, Total Internal Reflection, a topic of class 12 physics in chapter optics. So we will start the topic. We all have studied about reflection in our class and we have studied the laws of reflection. The first law says that all the normal, incident and refracted, all these rays are in a same plane. This is the first law of reflection. First law. The second law, also known as Snell's law, which says that the ratio of sine of incident angle and sine of refractive angle is always constant. You all know about incident and refracted angle. If I consider this is a two medium interface, let us consider air and this is water. And I project a ray from here on the interface. Then what happens? The ray will go through the medium water and bend towards the normal. This is the incident angle and this is the refracted angle. The angle of incident light from the normal is incident angle and the angle of refracted light is refracted angle. Now we will study what happens when the light rays goes from denser medium to clearer medium. First, I will create a boundary of two mediums. Let me start this is the boundary, and this is our point source. A point source is a source which will emit lights in all directions. This is a first ray in perpendicular directions, and I am considering this is the denser medium, for instance water, and this is rare medium. Considering air, we all know water has a refractive index of 1.33 and air has refractive index of 1. So this is a light point source and this is first light ray. If perpendicular, the incident ray is perpendicular, it goes straight. Then I draw the next ray at certain angle from the normal. This is incident angle and the ray will bend away from the normal. This is the initial trajectory and this is the new trajectory after passing through the medium. Next we will draw another ray from it. It will bend more away from the normal. This is the normal and this is more away from the normal. You can see I am increasing the incident angle and the refracted angle is increasing with time. Here the incident angle is 0 and the refracted angle is 0, but here it is more and it will go increasing. There will be a case when we find the refracted ray will bend such that it raises the boundary of the medium at certain angle. The boundary of the medium, the refracted ray will pass through the boundary of the medium. At this condition, this angle, incident angle is called critical angle. I am denoting it with C. C is critical angle. What happens here? The refracted ray raises through the boundary. And after any angle greater than critical angle, if the angle of incidence becomes greater than critical angle at the denser to rarer boundary, then what happens? This ray will get completely reflected. This ray will get completely reflected. So this is the case for total internal reflection. First, denser to rarer medium, and the second is the angle should be greater than critical angle. And these are of very high